Good afternoon, students. How are you doing today?
Good afternoon,
Good
sir. Doing
afternoon, sir.
fine.
Doing good.
Nice. Um, I'm gonna remember that we are starting a new topic today. Remember, um, we would have completed our trinomials. Um, what I will do with you for you now, as I'm thinking about it, is maybe to give you a one question to work for me. We spend about 10 minutes working that, and then we'll move into our trigonometry. How that sound? That
Okay.
sound
Okay,
okay?
sir.
All right, good. So give me 2 seconds. I'm coming back to you. Okay, guys, here goes. I just generated, I have not yet done the question. I just generated a question. So I'm going to do the question while you're doing it so that we can share our answers. So I want you to solve x cubed plus 3x squared minus 46x minus 48 equals 0. Solve x cubed plus 3x squared minus 46x minus 48 equals 0. Start working for me, please.
Sir, can you repeat, please?
X cubed plus 3x squared minus 46x minus 48.
Sir, can you repeat the first question as well, please?
I one question, McGee.
Okay.
Solve x cubed plus 3x squared minus 46x minus 48 equals 0. Start working, please. Everybody all right?
Yes, sir.
Okay, cool. Anybody finish?
Yes, sir.
What you got for your answers?
Sir, x equals -8, x equals -1, x equals 6.
Okay. Anybody else? Thank you, Shanti. Anybody else? No, listen to me now. I was in a meeting. Go ahead.
Sir, I
Go
got
ahead.
x equals 6 so far.
Get x equals 6 of r.
Yes, sir.
Okay. All right. So I was in a meeting today, and I was boasting about my Cape integrated math class. Literally boasting to say that when my students come to class, they look forward to their class on a Monday and Friday, even though the class is at 5:30 to 8:30, and they speak up in my class. That's what I said today. Oh, no, don't disappoint me and don't make me take back the talk here. So, especially when I'm going to be moving into a topic like trigonometry, we want to hear from you. All right. So, Tanil, hurry up for me, please. Shanti, I hear you. Anybody else?
Sir, I can look in your private chat, please.
Okay, thanks. We'll do. Oh, I know what the problem is. I'm not seeing it because I am logged on twice in Zoom. Okay, so this is the one that you sent it in. All right, checking now. Okay. All right, so I'm seeing some messages. Forgive me. I am in. All right, I see a message, dearest. All right, so I'm logged on twice. I'm logged on my tablet and to the computer that I'm sharing from. So that's why I wasn't seeing it. All right. Okay, Matthew, I see you. Is there anyone else though that has gotten it?
Sir, I got -1 and -8 also.
Okay. All right, take a minute. Congratulations.
Sir, when I did it in the synthetic division, when I did it that way, I used -6 and I got 0. But I think,
So how you use -6?
oh
Why you
yeah,
just jump to -6? Why you jump to -6?
sir, I don't know. Sir, let
Mm-mm.
me tell you why, sir. Sir,
Mhm.
when you were saying the question, I put x squared instead of x cubed, and when I used 6, I wasn't getting it. So I tried something else. And then after I realized that it was actually cubed. Sir, but I still get the answer.
All right. So when you told me you got x equals -16, I was going to say to you that means you got x equals something else also, and then I said no, don't answer the question that way. Because I was wondering how you got 6 to be the very first answer. All right. What I need to correct something, Tani, and the rest of you. You're going to do this in order. You're going to start with 1. You're going to start with -1 or 1. So if you go 1, it don't work, then we move to -1. It don't work, you start with 2. Don't work, you move to -2. Don't work, start with 3. Don't work, move to -3. By the time you reach 3, you must find your factor. Don't want anybody to jump into 4 and to 5 and 6 and 7 and 8. You will get yourself frustrated. Please, I don't want to frustrate anybody. So let's go again. When you get the question of this stage and they give you something like this to solve, you're going to start with 1. You don't get 0, you go to -1. You don't get 0, go to 2. You don't get 0, go to -2. Don't get 0, go to 3. And if you don't get 0 there, by the time you reach -3, you must get 0. Because we're not giving you anything beyond that. Please, I'm going to beg of you. Follow that procedure, you'll save time and you'll save some marks. All right. So look at it. This topic is really at its end. A few students saying that they're not following what is happening. Shanti, can you unmute for me, please?
Yes, sir.
I want you to walk the class through the solution of this question for me. And make sure you type it up so you can see exactly what is happening. Go through and just explain to them what it is that I'm right here, listening to the explanation. If you say something that is not correct, I will correct you. But I call upon you because you're the first one out of the batch to give me the correct answer. So go ahead.
So first I'm going to use trial and error to determine the factor.
Can't continue.
Oh, okay. So going to use trial and error to determine the factor, and it is x equals -1, and then you're going to substitute x equals -1 in the equation above, which is right here.
Press
Right there.
pause. Press pause, Shanti. You notice what I've done first. I was able to name my equation.
Oh, yes, sir.
Oh, I won. Not really a one. What's really happening? Hold on, guys. Hold on. I have no clue. Oh, it's not responding. Hold on a minute. It's responding now. All right, hold on, let me fix it. All right, one of the applications not responding. So yeah, so what I was saying to you is that notice I name my polynomial. I let D to be my polynomial, so I name my polynomial D. Then sir, I didn't name my polynomial F. Not a problem. Just give the polynomial a name so that you can refer to the polynomial. All right. Then she says using trial and error to determine the factor. And then she's saying that she's using -1 first. When she substituted -1 into D, she got it to be equals to 0. Take it from here now, Shanti.
Sir, are you sharing the screen or I should use my book? Okay.
Oh, I'm not sharing again. You have you can share your screen?
No, sir, I was just going to read from a book.
Sorry, you come back up. So let me see if I can share screen. Oh, hold on, no. You know so what happened? Yep, that's what happened. I got kicked out of Zoom from my laptop. Hold on. Are you seeing it now?
Yes, sir.
Right, continue now.
So therefore, x plus 1 is a factor of the polynomial. Then use long division. So should I explain each step? Like,
Why you want me to explain it?
no, if I should, like.
Duh. I can point it and explain it here. So go ahead. You're doing very well. Continue.
So x into x cubed, get x squared. X squared times x, get x cubed. There should be, so, okay. X squared plus x, x squared plus 1, you get x squared. X squared times 1.
X times it, please.
X squared.
And
then you're going to subtract.
And
you get 2x squared. Then you bring down.
Hold on, Shanti. Say x
0
cubed minus x cubed is 0. And 3x squared minus x squared is
2x squared.
And then you?
And you bring down the negative 46x.
Then you say
x into 2x squared, get positive 2x. 2x times 1, positive
2x times
x, right? 2x squared. And 2x times 1, 2x. Then you subtract.
Good.
2x squared minus 2x squared, you get 0.
Good.
Then negative 4x.
46.
Negative 46x minus positive 2x. You get negative 48x.
Good. Then you?
Then you bring down the negative 48.
Very good. Then you say?
X into negative 48x is negative 48.
Then?
Negative 48 times x is negative 48x. Negative 48 times 1 is negative 48.
And
Negative 4, then you subtract negative
Good.
48 minus negative 48x gives you 0.
Good.
And then negative 48x minus negative 48 gives you 0.
0.
Yeah,
Very good.
0.
You don't finish it in a mommy. So we don't know where it look like you want unmute. You know, finish it. Continue now. Then
Sorry,
what
no,
is this? What is this piece?
oh,
What is this? What is this piece called? The x squared plus 2x minus 48. What is this
sorry, the
piece called?
quotient from,
Excellent. So you have to tell them, you know. You have to
Oh.
tell the class. So we're gonna now solving.
now solving x squared plus 2x minus 48 equals 0, which was the quotient, right? And then I said a times c is negative 48. And then you're going to find two numbers that when you add them, you get 2. So those numbers are 8 and negative 6. Then you said x squared. You substitute the 8 and the negative 6 where the 2x is.
Good.
And you get x squared plus 8x minus 6x minus 48 equals 0. Then you group the terms.
Good.
Grouping them, you get x squared plus 8x minus 6.
In one bracket.
In one bracket, you have
Leave
x
out the middle
squared.
sign every time. Leave out the middle sign every time. Remember, you have to leave out the middle sign every time.
Yes, sir.
Continue.
After you group them.
And then what happened? Something happened here, so because the sign is negative 48. And then it became positive 48 right here. So what are you doing? You're factoring out a negative sign right here.
Yes,
So you got the middle sign, which is negative. So you're factoring out a negative sign. So whatsoever sign that is, you're factoring out the negative sign from the 6x and the 48. So it becomes now a positive 6x and a positive 48. And remember, whatsoever sign that is here has to be the same sign that is here. All right? Must be the same sign. Then what you say now? What is?
X squared.
What is common between?
Oh, x.
What is common between x squared and 8x
and
is?
8x is x.
And what is left is?
X plus 8.
Then you say to yourself, what is?
What is common between 6x plus 48? That is 6. And then you put back the negative. Oh. And then you get x plus 8 equals 0.
Then you see?
So two of those are the same. So you say x plus 8 and then you say x minus 6 equals 0. And you solve for x. So x minus 6 equals 0, x equals 6. X plus 8 equals 0, x equals negative 6. And then negative 8, sorry. So that is x equals 6, x equals negative 8, and x equals negative from above.
Very good. That one came from all the way up here, so. All the way up top here, so. Very good. Thank you, Sudie.
Sir,
you did
I
well.
was on the right track, but I wasn't finished solving.
Tatiana, I am going to shake out your curried lobster that you have on a Friday night and your fried fish. I'm going to share it among your classmates. But anyhow, I know you're understanding, so I'm going to give you some of the crumbs. So I'm not go back to you because I know you're understanding. Yes, Natty B.
Sir, never.
Not to be, if you ask me a question, ask me the question. You're
Sir,
uncomfortable.
I feel
Go
like
ahead. Hmm?
never mind.
Jesus, help me with Natalie. Natalie, you're uncomfortable with something. Talk to teacher.
Sir, never mind.
All right then. Very good. Let me ask a question. Is there anyone in the class that not seeing at all? What is that? Remember the topic finish, you know? Just a gentle reminder. Say it
Sir,
again. Yeah.
me.
Me who? What you're not seeing? What are you not seeing?
Everything.
Natty, I'm gonna ask you one secret here, but don't tell nobody in the class. I'm gonna ask you. Natty, you did do any work over the Christmas? Hello?
Sir?
Yeah, you did any revision over the Christmas?
I did already talk about that. So you make the whole class now?
Shh. It's me and you, nobody not listening. It's me and you.
Hearing, but don't like that. I wouldn't do
What's
that
your
to you.
what's your you're lucky. Because guess what? You're not alone. And I'm gonna pause and say something here. Give me half a second, please. All right. Hear me out, all guys. And I should have forgive me for not doing something today. And now that I remember, let me send it in the WhatsApp group. Because we are a family. Oh Jesus, who is sending to me again? Oh, I think I know. No. We are a family. And oh, I wonder if it's the right one. All right, I just sent something in the WhatsApp. And I want you to look at it.
Yes, sir, I saw it. I was shook.
You were shook?
Yes, sir.
Sante, you were shook?
Yes,
I was
sir.
shookun. I was shookun.
Sir, the
So,
exam is so early.
and
Sir,
that's it's when
integrated math.
the 2nd of May, you know?
2nd of May.
The 2nd of May. So, not to be, my aim here, honey bunches, is not to show up anybody, you know. There are 29 of you in the class, and the 29 of them are showing up. I'm not picking on anyone individual. You see, when I got this information today, I sit down with my hand on my head and I said, Jesus. I said, Jesus, what is happening? And I called the vice principal and I said to the vice principal, I don't know if I can finish the syllabus in time for the 2nd of May. Let me grab my paper and read what I wrote. I said possible weekend sessions to complete Cape Science syllabus. I had to speak to her about it because I don't know if something ever happened to only get under the belly start bubble up. That's what happened to me today. So when I asked the question if any work was done, it's not to show up anybody. But I want you guys to understand that when Sershand is moving, I am not here on a vacation. Real talk. Real talk. Me not lie to you. When I saw something today, I was like, oh my God. And a matter of fact, I want to tell you something, Shanti. I saw the second paper, the paper that was in June. So I said, what? The paper them in June, so I have enough time and then finish them exam, them can come back to me. And then I say, but I don't see one of the papers. And then I scroll to the end where them just give the the subjects at the time and I say integrated math, paper 2, the 2nd of May, and paper 1 in June, I nearly flipped. All right, so let me tell you where I'm going now. Gone are the days and the times when we are going to be pussyfooting around getting the stuff. I will not rush through the syllabus and you don't understand it, you know. But this is the point I'm making. And I'm making to 29 of you. You have to be working and working consistently. Because sir, now go able sit down and go through the something over and over and over again. The final thing I'm going to say to you that I said to the vice principal this morning, I said to her, we started the 25th of October. In the last week, when Matthew killed me, and rightly so, because I know you guys were tired and I too was feeling tired. So when we never did anything much in the last week, that's fine. And that's what I said to the vice principal. I said, the last week of school, and especially the 17th, very little took place because people were tired. Matthew said, sir, go easy upon me today, no? And I felt it because I too was feeling a little drained. And I said, oh goodness, the students are drained. Right? So I never really feel any way too much about it. But I'm only able to cover of the 8 units in module 1. I was only able to cover unit 4, 5, 6, and 7. Matter of fact, I didn't even finish 7 because this is 7. This one is one of them that I'm finishing up, but I finished it off now, right? And then to start the 5th unit, we not touch SBA. Matter of fact, on the same sheet of paper, I started writing your SBA question because the SBA will have to be, I can't tell you to go find an SBA. I have to be very specific in selecting an SBA topic and group students. So I'm going to tell you straight up, nobody now do no individual SBA. Nobody's doing any individual SBA because I don't have the time for that. We have to do group SBA. So you want to understand me. You want to understand me. This is very serious. Over the Christmas holidays, I sat up and I spent time and prepare your notes for you on trigonometry. My family members are saying, Lord Jesus, you get a little time for rest and you still at the work. We say, yeah, because school will open the 3rd, and based on where I'm at, I don't have anything on trigonometry. I have to sit down and prepare some notes. Thankfully, I completed my preparations. So I did work. All right. Fast forward now to January 7th at 6:40 p.m. I'm wanting to start work. I want you guys to start working. And when I come to class, you know, we not say, we have to understand everything when we do in a class, you know. All of you don't learn at the same pace. But by the next class, we're supposed to understand what I did in the previous class because you're supposed to know your level of understanding. And if you don't understand it, someone must sit down and try to get it. There is a WhatsApp group. Fling some messages in there. Oh, sir, get that number 1 year. Oh, sir, get this. Students, I'm expecting all of you to pass the exam. There are 1 or 2 students in the class that I have already identified who are working to get a distinction. And I see it. But I'm going to say to you, the rest of you, pull up your socks for me, please. And all the other garments. Because I'm not leaving you behind. And I'm going to get very miserable on you if it is that you're not pulling your weight. Is it because I don't like you? Far from the truth. With that said, let us get back to it. So for those of you who know, so they never do no work over Christmas, when the teacher have to sit down and do work and prepare for you, try make sure this weekend you go and catch up on the maths. Real talk. Real talk. I can be very nice, but one of the things that I hate is when I have students in my class who are lazy. Me not say you're supposed to be bright, but a trying student. Me and lazy students are no friend. And if you're my friend, you can't lazy. Me no want no lazy friend around me, because when me broke and want a money, me supposed to can say to my friend, oi, I want a $5,000. I mean now borrow it from a friend. I want it. So let's go again, guys. Sorry for the break in transmission. But while I think about you, I want you to think about you. All right. What was that note, Tatiana, about by something negative? Which one? Unmute and ask me the question, please. I just barely saw it come up.
So I don't understand when it's negative or positive. Like when
Which
it's supposed
one?
to be an add. So overall, when it comes to algebra, you wanna have any suggestions like video or anything?
When it's a negative, okay, I cannot get what it is that you're talking about. When it's a negative or positive, what do you mean? Give me an example. Like, give me an example. Show me where in this question that triggered the difficulty. Like when you're substituting this negative sign into this something here, or you get the positive or the negative out of it.
Yes, sir.
All right. So watch a trick. When I'm raising a negative number to an odd power, the answer is going to be negative, because it means I'm going to have -1 multiplied by itself 3 times. -1 times -1 is +1, and +1 times another -1 is going to give me this -1. But when I raise a negative number to an even power, your answer is going to be positive, and +1 times 3 is going to give me 3. Watch this other trick. When I multiply a -46 to a -1, when I multiply 2 negative numbers, I get a positive number. So TD, you have to go work on that. Know
Yes,
that
sir.
you know where your shortfall is. You have to go work on it. Oh,
Yes,
and
sir.
yeah, thank you. And incidentally, it wasn't trigonometry alone that I worked on for you guys. I've already completed calculus, the calculus notes for you guys as well. All right. So I'm just saying, it's the first time the college teaching integrated math. So none of the 2 lecturers have information on it per se. So we have to be preparing the stuff. I have completed calculus, the calculus unit, which is what we're going to be doing next. And then now I'm going to be taking my time to prepare the statistics module. So by time I'm finished with the calculus module, I should be finished with the statistics. I can present that to you also. All right. So we're looking like a good thing, but I should tell you, I'm a little worried, and I'm going to be very frank with you, because I want you to understand where we're working with. I'm a little worried because if the exam is really going to be in May, it means that the SBAs will have to go in by March. It means by the end of this month, I will have to, and I can't give you the SBA yet, because based on where I'm giving in the SBA, we have not started those topics yet. So I have to hurry to get to those topics in order to give you the SBA. All right. I'm hoping that by the end of this month, I can finish with module 1. And that's a big hoping, but I'm hoping that I can finish with module 1 and then use the month of February thereabout to go through the calculus module. It means that I have to go through pretty quickly. February, piece of March, and use piece of March, April to go through the statistics module so that we're ready for May. And I sent all of you the timetable, because I want you to see what it is that I'm working with. So when sir moving fast, it's really not sir having to move fast. I don't want not to complete the syllabus with you guys. I want to be able to finish everything. All right, let's go. All right. Natibi, you need to touch base with me after class. Thank you, please, ma'am. And don't make me fall out. We still love you, but don't make me fall out. Make sure say touch base with me after class. You hear me, mommy?
Yes, sir.
Okay, me think you're gonna vex and answer me. Me come through the phone for you. All right, cool. Still love you, mommy, but me have to tell you how it is. And that's how a teacher-student relationship go here. when the teacher make up noise for you, is not say the teacher not love it, the teacher looking out for the best interest. So nobody, Shanti, if me load you up too, it's not that me not like you. I'm looking for the best for you. All right, let's go. All right. What I'm going to do, oh Lord, this is putting me under pressure. Ay, ay, ay. Ay, 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 ay. What can I do? Is there, outside of Kimoli, is there anybody else in the class here that is an Adventist?
No, sir.
Okay, all right. There's a no. Oh Lord. I really hope I don't get back another weekend class so that I can even spend, like I have like a 2-hour tutorial session with you online, where we just come to class and just work questions. It's very important. It's going to be very important that we do that. So it means that I'd have to go and find questions, drop in the class, and then we'll work on those questions so that we can get enough practice. Because what is going to happen is, if you're not practicing consistently, you're going to forget some of the things that I would have already gone through. So I have more work on my hand. All right, never mind. We will get through this. We will get through this. Manifa, how you feeling now? Sorry, not Manifa. Manisha, how you feeling now?
Oh, sir, we get it.
You get it now, very good. Kesana, Green, how you feel now?
I'm okay, sir.
You sure?
Yes, sir.
Nice. All right, I'm going to ask the question one more time. Foxy, how you feel?
Good, sir.
All right. Melia, you all right?
Yes, sir.
All right, good. Miss Patrine, me notice if me not call to you at night time, me not talk to teacher, you know, but me and you all right, Mummy?
Yes, sir.
All right, good, good. All right, let me ask a question one final time. Outside of Natibi and I will have our conversation outside the class. Is there anybody else that is having a difficulty with this area? Let me know now. Okay, all right.
Yes, sir.
Okay, I hear a yes. Which meal was that? John Mark. What problems are you having, John Mark?
So today is my first class of the year. So.
Okay, all right. So you need to link
So
me also.
did you start the topic on Monday?
No, sir. That means never do no record at Christmas neither. This topic
Is it the last week of school?
Huh?
No. Is it
No,
the last week of school?
no. I started it before the last week of school. Yeah, man, I started it before the last week of school. All right, do me a favor, guys. All of you, I'm coming to you, Nikki and Tati D. Do me a favor. I already posted the recording from Monday's class. I don't know how many of you'd have seen it. What I want you to do for me, and what I have done is to label the recordings. So I will label the recordings as polynomial, synthetic division, whatever else the situation is. I want you to go through the recordings again. All of you to go through the recordings. And when you have a good time, you can go through, and like all them talking, we are the writer now, you can fast forward the talking. So at least, the 3 hours will come down to about maybe 2 hours, with the dead ear when you're working questions, you can and just play through the recordings. All right. So John Mark, we need to link. Nikki, what?
How many I try find the recordings to watch over, but sir, I may look, me can't find it.
You serious? Anybody can find them?
Yes, sir.
Yeah, man. All right, Tantan. Help Nikki from me, please. Outside the class, or little later after class finish, just help Nikki how to find them from me, please.
All right.
So we're recording.
Huh?
On YouTube.
On YouTube. On YouTube. All right. So Tanil is going to help you guys how to source the recordings. All the recordings are uploaded. The last one I uploaded was the one on Monday. Hopefully, sometimes the recording comes to me minutes after class. I'm not the one that downloads it. And sometimes it comes to me a day or two after class. As soon as I get the recordings, I'm uploading it to YouTube. So just check for me, please. All right. Here goes. Here goes. Here goes. Here goes. All right. So we're gonna start the trigonometry. You know what? It's 7 minutes to 7. I'm giving you a 7 minutes break. I want you to go bathroom or go drink some water, stretch out a little bit, because we're starting a brand new topic. And I want brand new minds. So I'm giving you a couple minutes. Take a little break right now, please, guys, and then we'll come back, eh? All right.
Yes, sir. Thank you.
Cool.
Sir, the synthetic division is the first time we did it. It's not there. It's not on your YouTube.
The synthetic division one is not there. It's not on YouTube.
Nope.
Mm. Mm, 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 mm. Oh Lord. I'm wondering, if I incorrectly labeled one of yours for my calculus one group. All right, let me look back at it. You remember which day we did that? Sorry, let me look back at it.
December 17.
December 17.
Yes,
All right.
sir.
So all right, let me just go on. December 17. December 17. Let me just check my inbox. Oh, my head hurts. December 17. Oh, that was the last day. Did I send you any? Did I send you any notes on it?
No, sir.
December 17. December 22. Yep, I'm seeing one that was, oh, that's classless. That's the meeting participants. I'm seeing one on the 18th. No, this is pre-calculus. Okay, I'm seeing something here. No, but this one is, sometimes the things don't come in at the same time. You know, this one's saying the 13th of December. That would have been the Monday. Have you seen the one for the Monday's class? The 13th?
Sir, what's last thing that we did here before the so I think it was the primers we were doing.
Um,
Sir, December when?
December 13th.
Let me check.
Right, let me open it and see. Oh, my head hurts. Right, December 13th would have been December 13th was we're doing looking at primers then. Problem with the file. Oh Lord, complete. I'm seeing the
Sir, after
primers.
December 10, I see December 15.
Oh, you don't see December 13th?
No.
All right. So, all right. I'm uploading December 13th right now. Based on what I'm seeing creamers. So I'm just going to put, this is K integrated math, CRAM, and I'm thinking premise and polynomials. All right. If that's not the correct label, I will relabel the stuff. All right. All right. It is uploading. December 13th is uploading. Oh, you know what happened? Now that I'm in the YouTube, I'm seeing where One of them was, hold on a minute, please. Is it uploaded fully now?
I'm not
Seen it?
seeing it yet.
All right. It is. I've just checked it. It said, oops, it is. What did I do? It's all right. It's going through. It says 95% processed. All right. Let me just. I saw something else. Let me just check on that one that I saw. So hold on. All right, this one is. Oh, that came in on the 18th. Oh, that's why I missed it because I came in on the 18th. There's one that came in on the 17th. Cape integrated maths. So one came in on the 18th and one came in on the 19th. All right, I'm seeing another integrated math populating right here. That could be, let me see. I'm sure I double send these things, you know. Okay, all right, okay. This is the, yep, this is the one you're asking about. Got it. Synthetic division. We're just going to call it polynomials. Got it. Keep. Come on. Keep integrated mathematics. And this is POLY nomials. All right, so they are, oh Lord, what does that mean here? Okay. You know, I don't like that something, you know. All right. The one that I did earlier is there. But this one that I thought was sent off wasn't sent. So that you're supposed to see that one now. The one that I did before this one. I have to resend the one I just did a while ago. Because it's not showing polynomial. Send a copy. Polynomials. Polynomials. Oh. Right. Title. Keep. Integrated maths. POLYNOMIALS. All right. So, and I think I sent this in 2 times. I think I sent one of them 2 times, but anyhow, you will see it. All right, so those are sorted out. Those are they. Those are they. All right. Let us see if we can get ourselves ready for this. Trigonometry. All right, so I want you set yourself into a frame of mind for us to have, oh, this thing's too bright, hold on. That's why my head hurts. For a conversation. Now, so 8.1 says to evaluate sine, cosine, and tangent of an angle given in radians, right? So radians, why radians? What is radians? So, you know, I did a little write-up when I was reflecting on the topic for you guys over the Christmas break. Why do we have to learn about radians? Isn't that a good question? I know if I were a student, I'll be answering that question now. Why learn about radians? All right. So many of you, many, if not all of you, think of a circle in terms of degrees. All of us think of it. We know that a complete revolution measures how much?
360
360
degrees.
degrees.
Yeah, man,
360
360 degrees.
degrees.
Yeah, man. As a matter of fact, I buy one we call it one pizza today, and then you look on one pizza, the first thing you look on is circle, portions, what sector come out, and then the whole parts of the circle come out, you know. You have the arc, you have the diameter, you have the radius. And remember, we don't say radiuses, we say radii, we're talking about more than one. And then we talk about the sector, we talk about the chord and the segment, major, minor, and, you know, whole heap of things. We talk about it. So it is a known fact that a complete revolution is 360 degrees, while in a semicircle, which is half of a circle, would be 360, would be 180 because it divides 360 degrees by 2, and so forth and so on. If I'm talking about what is the measurement in a quarter of a circle, of course, again, you know, is 90, all right? So, well, radian measure is just a different way to talk about a circle, another unit of measure. Put it this way, you can go shop and talk about pound of rice. But when you go to supermarket, you can't talk about pound of rice because the man them don't sell pound of rice. The minimum them sell is the 2.2. Well, you will get the pound of rice, but what you're going to but stop. So you can go to the supermarket, the shop, the corner shop, and ask them for a pound of rice. But when you go to the supermarket, you can't get a pound of rice. All right? Because what they will sell, well, in the good supermarket, that is, what they will sell is a 2.2 kilograms of rice, which weighs a little bit more than a pound. All right? So the supermarket uses one metric unit, and the corner man shop uses another metric unit. The supermarket won't sell a half a bread, but you can go to the corner shop and get half a bread. As a matter of fact, in some communities, you can get 2 slices of bread, if you, for that matter. Anybody know about that?
Yes, sir.
All right. So you may say to me, it's the same bread, but they're using a different unit to sell it. 2 slices. There is no way you can buy 2 slices of bread in the supermarket. It's pretty much the same thing here, right? So radian measure is just another way of measuring a circle when it is that we're talking about a circle. So the word radian sounds like the word radius. Talk truth.
Yes,
Yes,
sir.
sir.
Yes, sir.
Sounds like the word radius, right? So it so happens that radian has a close relationship with the radius of a circle. The radian has a close relationship with the radius of a circle. So don't be alarmed. Don't be too afraid of it. Not to be, are you with me?
Yes, sir.
Okay, thank you. I don't want to answer Mr. Leader. I'm more a bit chirpy. All right, so hold on a minute, please. Hold on. All right. So there's a close relationship. There's a close relationship between the radian and the radius of a circle. We're going to investigate that relationship in a few. All right. So let us look at the definition. It says a radian is a measure of an angle that when drawn as a central angle of a circle intercepts an arc whole length is equals to the length of the radius of the circle. Nobody don't understand what that means, don't?
No.
Me know. Don't worry about it. I wouldn't understand it either. That's why I put this link here to show you what it is that they're talking about. So we're gonna watch this link, and then when we watch it, then we're going to in the meantime, when it comes up, read it again. A radian is a measure of an angle that when drawn as a central angle of a circle intercepts an arc whole length is equals to the length of the radius of the circle. Sounds a wish, but when you see it, you will recognize what is happening. All right, so why is this thing not? Oh, you choose to open in this thing here. Hold on, it's coming up. Oh, come on, like today. Oh, oh. Right, it's coming up, but it's It's loading. All right, in the meantime, let me just reproject it so you can read the definition one more time while it comes up. It's still loading. Take a few minutes to read the definition and then see if you can understand what it's saying, please. One minute. You know what? It may be an easier thing if I copy it in that and open it into one of my existing. Okay, I should have done that from before because this one. All right, so look at it again for me, please. Can you see that?
Yes, sir.
Yes, sir.
Yes, sir.
So what it said, this arc length is 1 radian, and this arc length is the same thing as the radius of the circle. Can you see that?
Yes,
Yes,
sir.
sir.
All
Yes,
right.
sir.
Let me do it one more time for somebody who don't see it. So the angle is 1 radian and the arc is also 1 radian. All right. So with that said, let me go back to, so it says a radian is the measure of an angle that, when drawn as a central angle of a circle, intercepts an arc whole length is equal to the length of the radius of the circle. Can you agree with that?
Yes, sir.
Yes, sir.
All right. So in short, what it is saying is that the length of the arc is going to be equals to the radius of the circle. So the radian length is going to, which is going to be the radius of the circle there, is going to work out to be the length of the arc that is formed at that central angle. Got it? I'll give you the link, so when you get the notes, you can go back and look at it, so you can see what is happening. So what I'm saying to you is that 1 pi radian is equal to 180 degrees. 1 pi radian is equal to 180 degrees. Now, I want you to say this thing like about 7 times over, because this piece here is what we're going to be using. See it here now? Is ready? I'm ready to start calculating, converting between degrees and radian measure of an angle. So calculation time ready. So let us go through again what it is that we're doing. So it is that we can set the foundation, because I feel that somebody got lost a while ago. So let us go again. So we normally talk about the degrees when we talk about circles. All right. Now we're saying that we know that a complete revolution is 360 degrees. And I'm saying to you that radian is just another measure that we can use to describe a circle. It's not only in degrees. We can also describe the circle in terms of radian, the radian length, right? So the word radian sounds like the word radius, and it happens that the radian has a very close relationship to the radius of a circle, all right? Now the definition is a radian is a measure of an angle. It is the measure of an angle that when drawn as a central angle, which is the angle that is inside of the something, intercepts the whole length, the arc length, and it's going to be equal to the radius of the circle. That central angle is going to intercept it as the whole arc length, and that arc length is going to be equal to the length of the radius of the circle. All right. Now, 1 pi radian is equal to 180 degrees. Now, the general formula for converting degrees to radians is to multiply the number of degrees by pi 180, by pi over 180. All right. So the general formula, when we convert between degrees to radians, we're going to multiply by pi divided by 180. General formula for converting from degrees to radians, we're multiplying by pi over 180. So let us look at an example. We're converting 250 degrees to radians, and we're doing it to 2 decimal places. Now remember, sir said, when you're converting from degrees to radians, you're going to multiply by pi over 180. See here? Pi by 180. So all you're doing is multiplying this piece here by pi by 180. And of course, you know that this 250 degrees is in the numerator and this 180 degrees is in the denominator. So the degrees will cancel. So all you're going to be left with is pi. So you're going to end up with now 25 pi by 18 radians. Sir, then all you move from that now into 4.36. Thanks for asking. Grab your calculators. Grab your calculators. And what I want you to do for me is to put in 25, look at your calculator and see if you see pi there. Look at your calculator and see if you see pi on the calculator. Talk to me now.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. So what you're going to do is put on your calculator 25 and put the pi beside the 25, just like we have it, 25 pi, and then divided by 18, and tell me if you get your 4.36.
Yes, sir.
Yes, sir.
Great. Did everybody try that? Did everybody get that?
Yes, sir.
Good.
Yes, sir.
Now, when you're going to liquor school,
Sir,
yes, mommy. Sorry, I didn't hear that. You get what?
I'm getting tax error.
Go again. What brand calculator are you using? You're very muffled. Can hardly hear you.
Casio.
Casio. All right. All right. Okay. Do me a favor. Clear your calculator for me, please. All right. And put in 25. Look for the pi button. You may have to press second function to access it, but look for the pi button. And then you're supposed to see 25 and the pi sign beside the 25. Are you seeing that?
What do you mean about second function?
All right, do me a favor. Take a picture of the calculator and put it in the group for me now.
So we can take a picture of it.
What should I say?
on my phone to send it.
We're not hearing Kasana. Where say?
She said she
So
can't
she
take a
said she
picture,
cannot
sir.
take a picture because she doesn't have any space on her phone to send.
Then turn on your video.
Yeah, turn on the video then. Yeah, yeah. Turn on
Just
the
show
video.
your
Come see.
camera, you don't have to show your face.
You will know.
Oh, so you don't want help again? Put you. Kasana, turn on the camera so we can see what is happening, you know. You will need it for the class tonight, you know. Watch here.
Sir, can I turn the how you turn the camera again, sir?
And put the calculator in front of the camera. Oh, or you turn it on, or at the bottom of it, it says start video, and you just click on start video. Casey, come no. All right, well, just sorts that out. So I was saying to you, when you're going to liquor school, by the way, not to be, you got the 4.36 on it?
Yes, sir.
Nice job, nice job. Now, when you're going to liquor school, pi, what value they told you pi works out to be?
And she has shown you.
3.14.
3.14, don't?
Yes.
Or 22/7.
All right, do me a favor. Divide 25 by 18 for me and tell me what to get. 25 divided by 18 and tell me what to get.
1.38.
Multiply that by 3.14 and tell me what you get.
4.36.
Magic. 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 M-A-J-I-C-K. Huh? All right. All right. Now, I don't understand how all of them something you decide to come up on my computer and now. Oh, I'll keep.
Sir, Kesana is showing the calculator now.
All right. Hold. Almost a she make me something start freeze up. Hold on there. Jeez, all right. I'm using. I'll come in, Casey. Oh Lord. All right, my list is, all right, wait for the program to respond. All right, the program is not responding there. Let me try the other device. All right, let me pin you. I'll come in. I'm trying to pin you. All right. Let me see the scroll up to. All right, keep it right here. Is it over the EXP? Is that the pi over the EXP? Beside the answer, is the answer to the left, the EXP, the exponential button, the bottom row, the middle key in the bottom row.
Sir.
Above that, is that where it's a pi?
Yes, sir.
All right, so do me a favor now. Press 25, shift, press the EXP button. You see the pi come up beside the 25?
Yes, sir.
Magic. Then press ABC, third button from the top left. Then put 18 equal.
So what is the ABC for?
It's a division button. That's how you divide in fractions on that calculator.
Oh.
Ah, somebody learned something tonight. Yeah, man. That's the division button in fractions. So if you want to divide 5 by 8 in order to say that it's 0.375 or so, whatever it is, yeah, you just use the ABC button. That's the division button for that brand calculator, that model calculator. All right. So you see, you get the 4.36 now.
Yes, sir.
All right, go good. All right, thank you, Rihanna. All right. All right, where am I? Where was I? Where was I? Oh, I asked you to convert 150 to radians to 360 for me, please. What's the answer?
2.62.
2.6.
To 3 significant figures.
2.613.
To 3 significant figures.
2.62.
All right. You have to remember. You have to remember those things. You're like significant. All right. No, this thing is. Oh, gosh, man. Oh man. All right. I'm closing the program because this thing is not working out. Oh, Jesus. Oh. Oh my goodness, man. You know, I really need to sort out this computer, you know. Honestly.
All of the work, then when the teacher them send her to what?
Tessana, unmute for me. I mean, mute for me, please. Yes. Mhm. All right. And based on what she said a while ago, let me advise you to do something, guys. She is correct because I know I sent you quite a number of stuff through WhatsApp. I'm gonna challenge you that you create a either a Dropbox account or some cloud. Find some cloud, Microsoft Cloud, your Drive, your Google Drive, and download all those information to your cloud, and you can even arrange them in your subject area, so forth and so on. And the truth is, you can access your cloud from your device without taking up any space because it's not storing on your devices. So See if you can do that. It will free up a bit of space on your devices. Oh man. Forgive me, guys. Hmm. Guys, let me apologize here. I feel so embarrassed about this, but this is what happens when you have to depend on technology. And that's why I have to use multiple devices when I come to class, because it has a tendency to just shut down. It's a wonderful time to come back. Jeez, man. All right, let me just do my calculation. So I gave you 150 degrees to radians. And what was your answer? 2.62?
Yes, sir.
All right, good. All right. So while I wait on this program, restart the program. Oh, hell no. No, I restarted a while ago. No, not restarting again. Get away. Get away. All right. Do for me 225 degrees to radians. 225 degrees to radians. To 4 significant figures this time. I want 4 significant figures.
Sir, 201?
225. Let me know when you get the answer, you know.
3.927.
3.927 is correct. Everybody got that? Who didn't get it, say something.
Yes, sir.
Very good. 3.927 is correct.
Yes, sir.
All right. Let me give you another. What if I gave you 295 degrees to radians? And I want 2 significant figures in this one.
5.1.
5.1, yeah, 295, yes. And the answer is 5.1. Excellent.
So it would be 5.2.
No, 5.1. Because it's 5.1487. So it's going to be 5.1. It's going to be 5.1.
But the 4 would change to 5 because of the 8. I just no raise nothing. You just put it as it.
No, we're not so we do it. We're not gonna skip nothing to go round off from. We say 1 decimal place. We're going to look at the second one, the second decimal place, and if the second decimal place is 5 or more, we add 1 to the 1 decimal place. We're not going to look on the 3rd and the 4th and the 5th. No deal. Yeah, man. So I say it go here. Remember now, please. Important. Oh man, this thing just messed me up. Jesus. Very good though. Very good. You guys did pretty well. Without me having the document. Very nice. Now, let me ask you a trick question. Matter of fact, before I answer the trick question, let me give you one more for the road for those who don't see it. 55 degrees to radians. To one significant figure.
One.
One is correct. Very good. All right. Now, what formulation do you think we're going to be using to convert from radians to degrees? Somebody answer me.
Sorry, I mean by that. Sorry, I mean.
Sorry,
Huh?
repeat.
Multiply and square.
Okay, the formulation that we use for to convert from degrees to radians is pi divided by 180. What do you think we're going to be using to convert radians down to degrees? The reverse of it. That's a hint. We need to convert from
Multiply.
huh?
Multiply.
Think straight enough. Let me say it again.
Sorry, going to divide 180 by 5.
So
Very
pi
good.
times 180.
No man, the divide is 180 divided by pi. Remember, you're moving from degrees to radians and radians to degrees. So if you move from degrees to radians and you go pi divided by 180, to go the opposite way is on the inverse or the reverse of it. So you just flip it and say no, 180 divided by pi. Get me?
Yes, sir.
Yes, sir.
Yeah, man. So go through that for me now. I'm going to give you something. I want you to convert for me. 2 pi by 5. 2 pi by 5, meaning 2 pi divided by 5, radians to degrees. Two pi by 5 radians to degrees.
Sir, can you repeat, please?
2 2 pi by 5, 2 pi divided by 5 radians to degrees. What you got for the answer?
74.
Close. Check it again. Very close.
$72, sir.
There you go. There you go. Everybody agree with the 72?
Sir, me not again now. Wait, so must do again.
2 pi divided by 5 radians. Convert that to degrees for me. Look at what I did right there to calculate it.
Sir,
Yes, Papa.
where you get the pink part from?
Oh, that's a formula. So what I'm saying to you, Matthew, is a formulation for converting from degrees to radians. We say pi divided by 180. That's what we use. And I'm now saying to you, in order to do the reverse, in order to calculate radians to degrees, we're going to use 180 divided by pi. You follow me?
Yes, sir.
Right. So let me say it again. So to convert from degrees to radians, we divide pi by 180. But to convert from radians to degrees, we're going to divide 180 divided by pi. So we're just flipping something here because maybe one is the reverse of the other. So we got 72. Fair enough? Any questions? Any other questions?
Sir, can you go through the solution, please?
Somebody saying something?
Sir, can you go through the solution?
All right, you're very muffled. Who's speaking?
So she's saying to go through
Sir,
the
can you go through the
solution.
solution, please?
Oh, go through the solution. Okay. All right. So what I'm saying to you here is, watch me, Nikki. So the question asks us to convert 2 pi by 5 from radians to degrees. It asks us to convert 2 pi by 5 radians to degrees. Now, what I'm saying to you is, to convert from radians to degrees, I'm going to be multiplying by 180 degrees divided by pi. This. If I'm converting from degrees to radians, I'm going to multiply by pi divided by 180. So you have to know which of them to use. You're converting from degrees to radians, what to use, radians to degrees, what to use. One is the reverse of the other. Now, let me tell you how I used to study. It's when these two things are so close to each other, me study one. Me study smart. Me study one. And when them ask me for the other one, oh, it's the reverse. So because me did do degrees to radians, I mean, no says pi divided by 180, and that alone me study. Degrees to radians, it's pi divided by 180. And if them ask me radians to degrees, I will reciprocate it. 180 divided by pi. Done. Argument done. Me now go study the two of them. And then go get confused. Me studying one. And the one that I study, when them ask about the other one, it's the reverse. And that's what saved me many times over. This thing not working out, guys, because my computer going in circles again. I really don't know what is happening. I need to shut down the computer again, but anyhow, we'll soon finish. All right. Now, so Nikki, what I'm saying to you is, because I'm converting from radians to degrees, I'm going to be multiplying by 180 divided by pi. 180 divided by pi. Now the pi's will cancel, and 2 times 180 is 360 divided by 5, and that's why I end up getting my 72. That's why I end up getting my 72. Try this one for me, please. Convert 7 pi by 6 radians to degrees for me. 7 pi by 6 radians to degrees. I want all of it to be actively participating in class.
210.
210. Oh, you get so much. That not sound right. That wrong, man.
21, sir.
Oh, 210 wrong. Very good. I'm proud of you.
Sir, that me get my area say it wrong.
Very nice. I'm proud of you. Very nice. Very, very, very nice. The rest of you, are you catching on? This exercise is important for what is to come, you know. And I'm not scaring you, but I need you to understand this in order to move on. Talk to me. Are we okay?
Yes, sir.
All right, try this one for me. No, I don't want you to try that one yet. That's another thing. I want you to do 4 pi by 5. Aha, that's a tricky one. 4 pi by 5.
Sir, 144.
Very good. Nice. Nice.
140.
39 I forgot the pi, the calculator, I forget it.
You don't have to put the pi right. So you can just cancel the pi's. Don't in your head, don't it?
Yes, sir, this is 7 times 180 divided by 6.
Foxy, there's another trick to this that I'm not going to tell you, because what should happen is that you're supposed to be able to work this out into your headspace. Is I don't want to come to the class and go all of the information. So you've unraveled one of the tricks. Very nice. Very nice. Try this one for me now. I want you to do 2 pi by 15 to radians, to degrees. 2 pi by 15.
24.
There you go.
24.
There you go. Yeah, man. You so quick with doing this stuff? Yes, man. Because when you go through the other questions, them not, I mean, I don't think I'm going to get anything like this from the essay paper, you know. You may get a question like this on a multiple choice. But for sure, you're going to use this piece now to evaluate something bigger on the essay paper. All right? Final one. Let me see if I can trickifies you. Hold on a minute, please, guys. All right. Is there anyone in the class feeling a little uncomfortable with the conversions from degrees to radians and radians to degrees? Hello, somebody.
No, sir. Well,
You're not comfortable. You're not comfortable.
yes, sir. Yes, sir.
They're
Okay.
comfortable.
Okay,
I'm
Manisha.
comfortable.
Oh, Manisha, you're saying that you're comfortable.
Yes, sir.
Oh, okay, thank you, Manisha. Because I know you're a quick one, you know. So when I heard it, not comfortable, I was getting like, you're not comfortable with this, Manisha, and the other harder topics you're comfortable with. But yeah, Natty B, come talk to your uncle.
Yeah,
Oh, you're fine.
yes, sir.
Nice job, very good, sweetie. Nice. John Mark, how you stay?
Sir, I'm good, sir. I'm good.
Matter of fact, John Mark, you know, so one night I come to class and I call it him a fool. I call it him a fool and I say, who is John Mark? Where's no, yeah, man. Me come to class and I call you because you've been missing some classes. Talk through John Mark, don't?
Yes, sir. Yes, sir.
Yeah, man. Me come to class already, man. I'm a load you up big time, you know. Where's John Mark? Where's John Mark? I mean, I see you. By the way, Tyreek is in class. Mr. Power's not here tonight. No, John Mark, you can't do this to teacher, man. Teacher will load up, you know, you have to come to class. You know, our teacher role already, right? It mean good still, you know, but to come to class. All right, yeah, you will talk. All right. All right, there's no love lost, man. Everything good, man. But it's just that I want you guys to be here. All right. Now it's 7 minutes past. Based on where I wanted to get to tonight, I'm not going to get there because my system was giving a little problem. But Foxy, she is wearing her spectacles of brightness tonight, and other nights too, you know, but tonight it shone brighter. There's another thing to it, you know. Matter of fact, I'll get asked you before I even go into it. Foxy, are you seeing anything else? Tum 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 tum. Tum 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 tum
No,
tum.
sir.
You're not seeing anything else. All right. So there's another little thing that I wanted to bring across to you tonight. And here goes. So let us look at a special case. And here my question to you. Will we obtain the same result to convert 1.8 radians into degrees compared to converting 1.8 pi radians into degrees? Am I saying the same thing? Yes or no? Tricky Fives. This serious? Will we obtain the same?
I can get the same answer.
Yes, sir.
We're going to get the same thing?
Yes, sir.
Okay. So again, let me read the question. So I'm not saying that you're wrong, you know. All right. Will we obtain the same result to convert 1.8 radians into degrees compared to converting 1.8 pi radians into degrees? We're checking to see if there is a difference. And based on what I'm hearing, yes, sir, we're going to get the same result. Is there anybody else who figured that we're going to get something different? I mean, no people that right they don't know. I try calculating.
Not sure, sir. Not sure.
Not sure. Okay, and that's fine. That's why we're here learning, you know. So I like when it is that you are actively participating in class by giving an answer. I don't know the answer, so let us figure it out. I don't know the answer, so we're going to together figure it out to see what is what. So we are going to convert matter of fact. Convert both of them for me. Do the question for me. I want you to convert 1.8 radians into degrees, and I want you to convert 1.8 pi radians into degrees. I give you 3 minutes. I'm gonna get some water. and I've given you 3 minutes to work out the pair of those questions, work out 1.8 radians into degrees and 1.8 pi radians into degrees for me. And I'll come back in another few. Anybody finish it? What is the answer? Is it a yes or a no?
No, sir.
No, sir.
It's a no? The
No.
answer is a no?
Yes, sir.
You get two different answers?
Yes,
Yes,
sir.
sir.
What you
Yes,
get for
sir.
what you get for 1.5, 1.8 radians? What answer you got for 1.8 radians?
I think that's 103, I think.
103?
I don't remember, I never write it down. But I know the other one is 324.
Yes, sir. 103 nuggets.
All right, very good. 103.13. Okay, very good. What is the other answer?
Yeah, the 324.
324.
324? All right. What I like about this class is that you learn very quickly. And for the most part, that's very nice. Okay.
Sir,
Yes, please.
sir, did you? Sir, how both of them is in degree?
All right, then no. You have to talk up a little louder. Not hearing you so clearly.
Sir, how are both of them in degree?
How are both of them equal?
In degrees.
Oh yeah. Because we're converting, remember both of them are radians, Look at this, Danny. 1.8 radians into degrees compared to 1.5 radians to degrees into degrees. So both of them are converting to degrees.
Oh,
You see that?
yes, sir.
Mm-hmm. So converting both of them to degrees. All right. Now, very good. All right. Foxy, I want you to look careful because you saw something. I said something earlier. All right, let us talk through. Let us talk through it, and then we can maybe. I won't even go through the other stuff. I may send it to you for you to look at it and see if you can study it. But let me talk to you to something here. So I'm converting 1.8 radians into degrees. It says 1.8 times, when you convert radians to degrees, we are going to multiply 180 degrees divided by pi. This says 1.8 times all of that. So in my answer, I'm going to have a pi in my answer. In this case, because it's 1.8 pi radians, you recognize that the pi's were able to cancel out. So all I'm left with is degrees. Do you agree with that?
Yes, sir.
Yes, sir.
Good. So you also recognize that you see the same 324 right here. You remember I said something to you earlier about little school mathematics and pi. What's the value of pi for little school maths?
3.14.
Okay, do me a favor. Say 324 divided by 3.14 and tell me what you get for your answer. 324 degrees divided by 3.14 and tell me what you get for your answer.
103.1.
All right. Is it the same 103.1?
Yes, sir.
Yes, it is. So there is a difference when I say to you 1.8 radians to degrees versus 1.82 pi radians into degrees, right? Once it is that you don't have a pi there, the answer is going to be smaller because you're going to divide the pi into the stuff. When I give you the pi radians, just remember the pi is being cancelled. Foxy said it, Foxy says, sir, when you're converting, because this piece, the example 2, is what we've always been using, right? So we always, the questions that I gave you, I would say to you that 5 pi by 6, whatever it is, 4 pi by 5. So I'll give you a pi there, and then Foxy said, sir, you know that you don't have to, you can just ignore the pi, sir, and then just work it out. And she's correct because she saw this one here, example 2. So I wanted her to see the example 1 to see if I didn't give you the pi, that your answer, one of the pi's, sorry, will not be cancelled, will be in the question, and then no pi will have that value of 3.142 to 3 decimal places. And when you divide it out, you're going to end up getting your 103.13. All right, here my conclusion. It is clear that the difference between the two questions, there's a difference between the two questions above. Recall that pi is a number approximately 3.14. Oh Lord, supposed to be 3.14 here. 3.142. So the difference between 1.8 radians and 1.8 pi radians is indicated above. So that is 1.8 pi radians is 3.142 times more than 1.8 radians. I gave away the piece of the answer from before, but are you seeing what I'm talking about here now?
Yes, sir.
Yeah, man.
Yes,
Just remember, there is a difference between 1.8 radians and 1.8 pi radians. 1.8 radians don't have the pi in there, so therefore your answer is going to be smaller because you end up dividing by 3.142. When I say 1.8 pi radians, the pi's then going to cancel out, so your answer is going to be bigger in degrees, the 324. Just remember that. And finally, I just want to walk you through. These. I won't even go through that, but just to walk you through these diagrams. Easy 1, 2, 3, and then we end. Easy 1, 2, 3. So we need to develop the basics 30, 60, 90 triangle, right? Ratio, right? So we need to develop the basic 30, 60, 90 triangle ratio. Now, there is a specific relationship with the 30, 60, 90. For those of you who do technical drawing, will have a greater appreciation that in your geometry set, you have a compass. The compass is the one that you can put your pencil in and draw circles. And then you have a divider. What do you use a divider to do? Anybody, somebody?
We don't draw on paper anymore.
Good answer. Good answer.
No, but it was for you. They have a software that they use now. CAD.
No. Oh, I thought you were talking because of COVID.
It changed. They're using a software now.
Oh yeah, man. AutoCAD you're talking about.
Yeah.
Yeah. But in my days, we never have no AutoCAD. Miss, me not so young, you know. In my days, we never have AutoCAD. So we had to use what we call divider. So the other two things, other metally looking thing in the geometry set is called a divider. Now, when I go to class and ask students what is the other thing for it, some students will say to me, sir, that's what we used to fight with, sir. I said, no, it's a divider. What you use a divider to do, if you want to measure and align the distance, 5.2, you can go ahead and measure 5.2 on the ruler using your divider and then transcribe it onto paper. But yes, AutoCAD is what they're using now. These nowadays students are learning the new technology. I never used AutoCAD until university days. All right. Now, we have a protractor. And tell me how you guys describe the protractor. The protractor is described as what? Let me see if you're not real student. Or half what?
Moon.
Very good. See, you're real students. Half moon, right? So when you go to class, half moon, yes, sir. You know, see, it look like what's up. So, oh, yeah, the half a circle. That's a protractor. And then you're going to have two triangle looking something. What are those two triangles? Well, of course, you're going to have your ruler. Everybody knows what a ruler is. The two triangles something. Do you have a name for the triangles inside here?
Set squares.
Yeah, good answer. See here, set squares. But it does, okay, so the set squares have specific names. Anybody know any specific names for the set squares? No, anybody? What is a scalene and what is an isosceles? Which one is a scalene?
Triangle.
Okay.
Longer skinnier one.
The longer one. And what is a scaling triangle, please, Stanton?
Sir, a scaling triangle has two equal sides and one unequal.
It has what? I'm not hearing it, honey. It has what?
Third, all three sides are unequal.
And angles too.
Angles.
Sides and
Oh,
angles.
angles.
Angles and sides. So you're correct, Tennille. So the scaling one is a longer one. It has all three sides and angles being different. No, the 60, 30, 90 is a scaling triangle. You see, one of the angles inside here measures 60 degrees. One of the other angles measures 30 degrees, and the other angle measures 90 degrees. So that's why we call it the 60, 30, 90 triangle, right? But Tanya, you know, bright. She's a scaling. We don't even know what scaling triangle look like. But she bright, but you're right though. And then the other one is a, what is it? Tanya, the other one is a what?
Isosceles.
And the other one is an isosceles, because the other one is a 45, 45, 90. And an isosceles triangle says two sides are equal and the angles formed at the base are equal. So you see we have two angles in there being 45. So this is real geometry now. And we're going to rely on our geometry now. So look at what is happening. So yes, correct, Tanya. The scaling triangle is what it is that we're looking at here. So this is how we're going to develop it. And I'm going to send you these notes so you can read over, but I just want to talk about it now. We're going to draw a triangle with sides of, with side lengths of 2. With side lengths of 2. That's the first step. So you see we're drawing a triangle, and incidentally it's not equilateral. This more looks like an equilateral triangle, but it's really not equilateral. Eh? But in this case, because we're drawing, well, it is equilateral in this case, but what we're developing is a 30, 60, 90. But this triangle here that I'm drawing is an equilateral triangle because the three sides are equal. It means that the angles are also going to be equal. So when I draw this equilateral triangle of side lengths 2, my second step, I'm going to cut in half. Then I'm going to be using Pythagoras to determine the new side, which is going to be from here so to here. So if I cut this in half, it means I'm splitting this piece here in half because it's an equilateral triangle. So that means over here is going to be 1, and over here is going to also be 1. Now, Pythagoras' theorem says the square on the hypotenuse is equal to the sum of the square of the other two sides. So this square minus this square is going to be the square root of this. So 2 squares is 4. 4 minus 1 squares is 1. So 4 minus 1 is 3. And this is where we get the root of 3. That's where we got the root of 3. And step 3 now is that we're going to be using the trigonometric ratio. See here now? Now down here says 60. This is your 90-degree angle. And up here says going to be your 30 degrees. This hypotenuse still remains the hypotenuse, or if you want to call it a slant height. This is going to be the perpendicular height of the triangle, which is root of 3. And this side here is going to be 1. Now, what I want to point out to you is that there are 3 different measurements on the triangle. The smallest of the 3 is 1. The second smallest of the 3 is root of 3. The root of 3 is something like 1.73 something. You can check it and let me know. The root of 3 is 1.73 something. And of course, the hypotenuse, I'm correct?
Yep.
Good. And the hypotenuse is the longest side of any given right angle triangle. So look at what happens. The longest side of the right angle triangle is across from the largest angle. The smallest angle is across from the smallest side. And the second largest side is across from the second largest angle. So they can't go wrong, right? So, you know, make sure you always set up this, no, you can't go wrong. 1, 2, root of 3. The hypotenuse is always the longest side of a right angle triangle. Then you will have the 60, 30, 90. Across from the 60, we have root of 3. Across from the 30, we have 1. And of course, across from the 90, we're going to have 2, which is your hypotenuse. All right, watch this story now. It says the side opposite the 30 degree angle is always the smallest because 30 degrees is the smallest angle. The side opposite to the 60 degree angle will be the middle length. And this finally the side opposite to the 90 is going to be the largest, which is your hypotenuse. All right. That's what I just explained a while ago. Now I'm going to be looking at a special case. So here goes the 45, which is your isosceles triangle. And this one, as Tanit says, is going to be your scalene triangle. Now you notice the orientation of this triangle is different from the one that I have up there, but it's not a problem because you can figure it out. You know where your 90-degree angle is. Across from your 90-degree angle, you're going to have the hypotenuse. So over here, so must be the hypotenuse if this is the 90-degree. Across from the 60-degree angle is going to be the second largest side. So the root of 3 has to be on this side. The root of 3 has to be here. And across from the 30, you're going to have the 90-degree. Across from the 30, you're going to have the 90-degree. All right? We're not talking about the 45 just yet. We're going to leave the 45. So the basic 36 to 90, that's what they call it, 36 to 90 triangle ratio. You're going to have the side opposite to the 30 degrees is x. The side opposite to the 60-degree angle is going to be x times the root of x. And the side opposite to the 90-degree angle is going to be 2x. Sir, why give us this? Because they can give you this triangle in multiples. They can give you this triangle in multiples. So if they give you this triangle in multiples, this is what you're going to be using. All right? And finally, I am speaking of the trigonometric ratios. SOHCAHTOA, as you know it, when I'm teaching trigonometry, I teach it. The old ass sits on his chair and hollers. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over hypotenuse. And then I'm ending right there. On Monday, all being well, we're going to be looking at some questions. How to convert cosine of pi by 6. You know how to convert these things already, but we're going to be converting those. But guess what? I'm going to be introducing you to something called the unit circle. So if you know this unit circle, any angle at all you want to find, you can go ahead and find it using this unit circle in degrees, and we also have the unit circle in radians. All right. So what I'm going to do, I'm going to send you the unit circles so that you can see what is happening. So you can do some light reading for me in preparation for class on Monday. All right. Thank you. Have a good night.
Sir.
Yes, sir. Sir, can I send this synthetic division PowerPoint as well, please?
We'll do for you. We'll do for you. We'll do for you. Yes, Matthew.
Yeah, as next class we can just review back over the triangle. I don't think I got too much that, you know.
All right, no problem, Papa. No problem. Go away, boy. Exactly. All right, no problem. We'll do for you. As I normally do, when I come to class, I normally review what I did before, but sure, no problem. All right, all the best. Say your gentle Jesus, please. Yeah, man. Come on. Yeah, man.